This problem reads, an 80 kilogram student stands on the left end of a 240 kilogram log which is floating in the water, which you may treat as a frictionless surface. The student and the log are both initially at rest. So here we have a student standing on the log, and on the log there are points marked A, B, C, D, and E. And some key words to note are that the system is frictionless, and both objects are initially at rest. So frictionless, initially at rest. For part A, it asks us to figure out the approximate center of mass of the system. Now, center of mass can be defined as a position defined relative to a system of objects and is the average position of all parts of the system. Since the student is standing on the left end of the stick, we know that the center of mass of the system cannot be C or A. This leaves us with B being the approximate center of the mass. So B is the approximate center of mass. Part B asks us to describe the motion of the log while the student moves to the right at 2 meters per second. To find the motion of the log, we could use the velocity of the center of mass formula. So VCM equals mass of the first object, which is the student, times the velocity of the first object, which is the student moving, plus the mass of the second object, which is the log, and the velocity of the log, over mass of the student plus the mass of the log. So when we plug in the values, which is 0, now the velocity of the center of mass is 0 because there are no external forces acting on the system. So since there are no external forces acting on the system, the velocity of the center of mass stays 0. Mass of the student is 80. It's moving at 2 meters per second. Plus the mass of the log is 240. So 240 times, well, we're solving for the velocity, so it's just V2. And you add the mass of the student, 80 plus 240. And then once you solve for V2, you'll end up with V2 equals negative 0.67. So since we have negative 0.67, this means that the log is moving to the left at 0.67 meters per second. Now part C asks us for the velocity of the center of mass, but as we already discussed in the previous problem, it's 0. And so another reason for this could be found from using the conservation of momentum. Now because the initial velocity of the center of mass was 0 and no external forces are acting on the object, the velocity must still remain 0, which gives us 0 meters per second as the final answer.